Okay, today we're going to look at multiplication of matrices. In our last lesson we looked at what matrices were. We talked about the dimension of dimensions of matrices. We looked at the different types of matrices, and then we looked at the addition and subtraction of matrices. And one of the things that we noticed was that to add or subtract matrices, they had to be of the same dimensions. Now we're going to look at multiplying matrices, which is slightly different. And it's a little bit more tricky, but once you get the hang of it, it's not too much of a problem. So hang in there, don't give up, and don't be discouraged. Now, when we're talking about multiplying matrices initially, we'll start off with just scalar multiplication, which is when we're talking about multiplying a matrix, a whole matrix, by a number or a scalar. So the example that we have is we've got matrix A, which contains the elements 1, -2, 2, 0, -1, and 3. And if we want to multiply A by 3, then what we're going to do is we're going to multiply each element within matrix A by 3. So you can see here we've got 3 times 1, 3 times -2, and 3 times 2. Then we go to row 2, we go 3 times 0, 3 times -1, and 3 times 3. Now these the products of each of these are just put in as is. So 3 times 1 is 3, 3 times -2 is -6, 3 times 2 is 6, and so on. We end up with 0, -3, and 9. Now, we haven't done anything other than multiply each of these elements by 3, and we've left each of those elements where they go normally. Now, that's just multiplying it by a whole number or a scalar. Okay, when we start multiplying one matrix with another, that's completely different. So please be aware of that as we move on. When we multiply matrices together, it is relatively easy, but there's a little bit of a trick to it. So we need to multiply the rows of the first matrix with the columns of the second matrix, adding those products together, and I'll show you exactly what we mean. So here we have matrix A and matrix B, and we want to find the product of A and B. So we're going to multiply these two matrices together. Now first what we do is we multiply across the first row, across here, and down the first column of our second matrix. And we add the products together. All right, and when we find those, we put the answer of that in the first row, first column of our answer matrix. So first, it's best to put our matrices into rows and columns. Put your first matrix into rows, second matrix into columns, because that's the way we're going to multiply them together. So let's start. We start off with the first two elements. So we're going to go 3 times 2, and we're going to add that to the product of -2 and -1. So we end up with 3 times 2 plus -2 times -1. Now we're going to go across to our third element here. We're going to go 1 times -3. And that's going to be added to the products of the other two products, and that will leave us with 5. Now 5 is going to become the first entry or the first element in our answer matrix. Okay, so you're going to need to label your matrices really carefully. So make sure that you label them as stated in the question. So if this is A, label it as A. B, label them as B, and then label your product matrix as AB. Okay, very, very important. Now what we're going to do is we're going to multiply across the first row and down the second column. So we're going to have 3 times 4 plus negative 2 times 3 plus 1 times 1. Now that gives us 7, and 7 is the second element of our answer matrix, and that will go in row 1, column 2. So you'll see how we've started off on the first row, okay, and now we're going to move to the second row. We're going to multiply across the second row and down the first column, and we'll put the answer in the second row, first column of our answer matrix. So we're going to start off with 0 times 2, and then we're going to add that to 4 times negative 1. And we're going to add that to negative 1 times negative 3, which will give us negative 1, and negative 1 is the product of all of those, and that's going to go, or the sum of all of those products, and that's going to go in the second row and first column of our answer matrix. Now we're going to simply multiply across the second row and down the second column, and we'll put the answer in the second row, second column, the only remaining spot left. So we start off with 0 times 4, we add that to 4 times 3, which we add to negative 1 times 1. That will give us 11. So 11 is our last element that goes into our answer matrix. So the product of A and B becomes 5, 7, negative 1, and 11. All right. Now notice the sizes of A and B and the size of the product of A and B. Now you'll see A is a 2 by 3 and B is a 3 by 2. So we've got 3 rows, 2 columns in B, 2 rows, 3 columns in A. Now, it's very important that we understand how to multiply matrices and whether we can multiply them or not. Okay, we need to look at their dimensions first of all. So, if we look at these two examples, so first one, this is rows times columns, rows times columns. This being matrix 1, this being matrix 2. Now if we want to multiply matrix 1 with matrix 2, we need to ensure the following. Okay? The columns in matrix 1 must be the same as the rows in matrix 2. So here, remember, we've got rows and columns, rows and columns. So the columns in matrix 1 must be the same as the rows in matrix 2. Then, the rows in column 1 multiplied by the columns in matrix 2 give us the size of our product. So as an example, before we get to that, if the number of columns in A does not equal the number of rows in B, so we're talking about the number of columns here, if they're not equal to the number of rows in B, then the product of those two matrices is undefined. And if you are asked in a question to multiply two matrices together and they don't have the number of columns in matrix 1 equal to the number of rows in matrix 2, then you would say it cannot be done as the product is undefined. So really important that you answer it that way. Now, let's have a look at the product of B and A. It's going to be slightly different. So here are the same two matrices that we used in our first problem. So matrix A, same elements, matrix B, same elements as well. Now again, first thing we had to do was go through, separate our rows in our first matrix and separate the columns in our second matrix, because remember, we're going to multiply across the rows of matrix 1 and down the columns of matrix 2. Now, matrix B is a 3 by 2, matrix A is a 2 by 3. So, number of columns in matrix B is the same as the number of rows in matrix A. So we can multiply them, and the size of our answer is going to be a 3 by 3. So we're going to need a 3 by 3 matrix for our product. And if you think back to what we had in our first matrix, it was rather different. I think we ended up with a 2 by 2. Okay, so across the first row, as we go down the first column, so we end up with 2 times 3 plus 4 times 0, which gives us 6. Then we go across the first row and down the second column. So we end up with 2 times negative 2 plus 4 times 4, which gives us 12. Now we're going to go across the first row and down the third column. See what we're doing? We're staying on that first row and we're going down each of the columns across 1, 2, 3, and we end up with negative 2 as our third element. Now we're going to switch down to row 2 in matrix B, and we're going to multiply down the columns in matrix A, starting off with column 1. So we end up with negative 1 times 3 plus 3 times 0 gives us negative 3. Then we're going to go negative 1 times negative 2 plus 3 times 4, which gives us 14. Then we're going to end up with negative 1 times 1 plus 3 times negative 1, which equals negative 4. There is our next element. So third and final row in matrix B, and we're going to multiply that down the rows of matrix A. So negative 3 times 3 plus 1 times 0 gives us negative 9. Negative 3 times negative 2 plus 1 times 4 gives us 10. And then finally we have negative 3 times 1 plus 1 times negative 1, which gives us negative 4. So our product of BA is a 3 by 3 matrix, whereas when we had looked at the product of AB, we had a 2 by 2 matrix, didn't it? So it was completely different. So remember, when we multiply matrices together, they do not have the same commutative properties as we normally look at. So A times B is not equal to B times A, because normally when we look at multiplying things together, we think of the commutative properties. So if we went 3 times 4, that equals 4 times 3. Not in this case. We're talking about different sized matrices, and it's not going to be commutative, so be really careful about that. Okay, now to find the inverse of a matrix. All right, if A equals A, B, C, D, and we want to find the inverse of that matrix, what we do is we swap the leading diagonals. So we go, let's swap D with A, and we're going to make our other diagonal multiplied by negative 1. So we're going to go negative 1 times B, negative 1 times C. So we end up with, see here we've got those two swapped, D and A are swapped, and B and C have been multiplied by negative 1, giving us negative B and negative C. And we'll talk a little bit about inverse matrices in our next lesson. Okay? I'll see you then.